So note that the tensile area is divided into two, so the AS1 and the AS2, to balance the compression forces given by the concrete area AB and compression steel area AS prime. But later on, we will not actually be using a separated area, simply because we want to simplify the formulation of the solution to double reinforced beams. We can actually do it separately, but it's easier to always uh, look into this concept for you to understand, no? But actually, the steel area for AS1 and AS2 may or may not be treated separately. So for your ductility provisions, take note that the derivation of the maximum steel ratio for doubling force is done in the same manner by simply considering the triangle here to capture the epsilon s prime, and the bigger triangle here to capture your epsilon cu. Okay, so the proportion is such that your epsilon s prime is divided by this distance here, which is actually c minus d double prime. So this must be divided by c minus d double prime is equal to this side here divided by the total vertical side c. Okay, so this is the corrected proportion. So this is by ratio and proportion. So fs prime now is, we note that your epsilon s prime is simply equal to the stress divided by the modulus of elasticity. So we can actually substitute epsilon s prime here and then put c minus d double prime on top there and divided by c, such that your final equation, by simply assuming a value of 200,000 and multiplying it by 0.003, you get 600. Okay, so this is now your formula to check if your steel fs prime stress yields. Okay, so if it is greater or equal to Fy, then it yields. If not, it does not yield. Okay, so take note that the formula for the singular reinforce or the tension reinforce Fs is simply equal to 600 d minus c all over c. Okay, so you have to bear in mind that these are two different equations. So for the equilibrium of forces, in order to derive the reinforcement ratio for double reinforced, we simply use the uh, couple, which is now C1 plus C2. So C1 is the compression force due to concrete, and this is the compression force due to the compression steel. Okay, so it is equal to 0.85 FC prime A B. Okay, so take note that A is equal to beta 1 C, where A balance becomes beta 1 C balance. So we simply substitute this A. Okay, so our original equation for concrete is 0.85 F prime C A B, but this is a balance condition. Therefore, we inserted the beta 1 CB there and then multiply it by the B width. Okay, so this is a subscript that's not this, that is the width of the beam. So take good care of this equation. And if we add the AS prime, FS prime, the concrete in, the steel in compression there, we actually have the total compression force C must be equal to your P. Okay? And if we divide it by BD, the area, we have to divide this also by BD. We can come up with the reinforcement ratio in terms of a raw balance and raw prime. Okay? So take note that the reason why we are dividing this by BD is to convert your area of steel to a reinforcement ratio. Okay, so always raw, balance, this is the reinforcement ratio, the balance condition, this is the reinforcement ratio of the steel in compression. Okay, and the reinforcement ratio of the steel in tension is simply AS over BD. Okay, so what about M? So M is Fy over 0.85 Fc prime. So we actually remove Fy here and multiply Fy at the bottom. Okay, so we simply transpose it there, such that this part here, 0.85, okay, is actually your 1 over M. That's why there's an M below. Okay, and beta 1 remains, beta 1 over M. Your BD will cancel, B, D, D cancel. So this is 600, what remains is 600, 600 plus Fy plus raw prime. So this becomes now your raw prime. Okay, this one. Fs prime divided by Fy. And notice that AS balance over BD is the original, this is now the reinforcement ratio of your double reinforced beam. No? So this is raw B is ASB over BD, but then since this is a double reinforced beam, we just add the double reinforced beam here. Okay, so this is now your formula for the double reinforced beam balance steel reinforcement ratio in terms of a singly reinforced. So remember, this is the derived formula a while ago, plus rho prime Fs prime over Fy. So if we apply now factor of safety just the same of 1.33, we divide this by 1.33 and we come up with a 0.75 rho BSR there. Okay, plus this one. So with this we do not divide because this is already ductile. Steel is already ductile, so we don't have to make it more ductile. Okay, so this is now the upper limit for a double reinforced beam, which states that simply your doubly reinforced beam is more ductile than a singly reinforced beam. Okay, so note that for the lower limit, the raw minimum for double reinforced is the same with that of the singly reinforced. Okay, so this is the one that I'm referring. So this is whichever is greater. Okay, so on the next video I will be showing you a problem on doubly reinforced beams.